Hi, my name is Dejan Knežević. I'll talk to you today about troubles and troubles with Python's dependency management. It's a dependency hell, and if you haven't been there, you will be. Okay, so Python packaging is not easy or simple. It looks easy on the surface. You install some packages, just packs them up somewhere. You don't know where they are. Basically, it just uses folders to pack in source distributions or wheel distributions. But problem is, only one version of a certain package is allowed with Python, unlike some other languages where you can install multiple. So conflicts can happen. There are many different ways currently for solving this. PyProject Toml is a new file that's supposed to replace setup py and requirements txts. It's an accepted PEP. It's going to take quite a long time before it's implemented anywhere. Poetry, pipenv, and hatch are new dependency management tools that will do basically everything for you. You just use them to install everything you need, and you use them for deploys. The problem with them is they're pretty opinionated, so they decide basically everything. You can't configure too much with them. There are also constraints files which were added in pip that are used for dependencies of dependencies, though that can be tricky to read, and you have to write it manually. Now, not tracking dependencies of dependencies and only using requirements files for only the basic things you use can cause some critical bugs. Now, a more personal issue was what we had at Seven Bridges. Several of our deploys failed pretty spectacularly in a very short span of time. So it took some detective work. We found out that, for example, setup tools had a problematic version with some of our dependencies, and it broke certain builds in certain times. Now, since we didn't track setup tools versions, this is what caused the problem. We encountered daemon dependencies as well, which means, say, multiple packages require different versions of the same package, and we couldn't see that with our setup right there. So we need the solution. The naive one is to use pip freeze and to save just all dependencies you're using into a requirements txt. This works in theory, but it can cause too many packages that we're not using at all to be in our requirements files. It can cause bloat, and it becomes hard to follow the changes, or just what have we changed in our dependencies. For example, if you install IPython, you'll have tens more dependencies that you're not actually using in your project. Now, also with packaging in Python, you can have source distributions that can overwrite other packages if they have the same name, for example, and you won't be able to track this way. Now, we decided to use constraints files in the beginning, but tracking all of them manually was pretty difficult. So we decided to write a tool that will check the dependencies and see if they're compatible, and basically just use it as a validation tool. So we created a Dante, which is an apt name for this. Still has problems. It used several packages on its own, has its own dependencies, so they had to be manually removed from the resulting constraints. But still far better than a previous situation. It worked for a while, but pip then updated to version 10 and broke everything, since Dante depended on pip, and they very often changed their internals, which I didn't know until then. And Dante had to be locked to version 9, which is not ideal. It works still, but it's not a long-term solution. You can't keep it that way too long. So we needed a new approach, and we vendored all the dependencies to Dante. That's not the entire setup tools. For example, it's package resources, just a tiny piece of it that we need for reading installed packages from the system. So here's a new proposed solution. We use a requirements txt file for all requirements that we directly use in the project. For example, you use Django, you just put in Django there. So requirements log file will lock down all required packages for that specific project. On the other hand, we can have development tools like PyTest or Flake or anything like that, and use dev.txt and devlock to specifically lock down our testing environment as well. Now, when deploying, we only install from log files, and that way we make sure we always have this exact same environment. And exact versions will be enforced in those log files, so only equals will be used there. So what we're left with, requirements.txt and lock, and dev.txt and devlock for all testing, for basically all our packages. And now we have Dante as a CLI tool. We'll show you how it works on the top level. So Dante basically has a version flag, which will just print out the version. Ignore will allow you to add packages that you want to ignore from the results. Basically, if you want to, if you have a tool that's specifically your own, for example, PyLint or something like that, you want to ignore it from your environment, but you want it installed, you can add it to ignore. All this can also be configured in setup CFG, which is a basic configuration file for Python. If you use all, you will get all packages which will ignore everything except the default ignored file, like Dante, pip, wheel, and setup tools. Dependency list. This is basically similar to pip's own command, since pip has later added not only freeze but the list. That's a more formatted type of that command. Dante list, on the other hand, will only show you packages that are relevant to this project. So it will go and read all installed packages, then use all requirements files to determine which packages are you using actually in that project, and ignore everything else. So if you have, for example, IPython, and you haven't set it up in requirements.txt, it will ignore it and all its dependencies. Here's, for example, Dante's list command will print out all the packages that you're using. For example, you can see there's no Dante, there's no setup tools, wheel, or pip here, while pip's list command will show you all those packages right there. It's a very similar format as well. Okay, so you can also add a dependency tree, which will show you somewhat of a more like forest the representation of all the packages installed in your environment. You can override requirements files by passing them here, or you can use the ones defined in your setup CFG. And you can also check for a specific package its own tree to display it for you. For example, here's a PyTest COV for PyTest and coverage. This is how it will look. The top level packages will show you the installed versions, while all the others will show you their installed versions and the version their parent requires of them. So for example, we can see 6 repeated multiple times. It shows you pathlib2 requires more than 2.2, and PyTest requires more than 1.10. Now, conflicting dependencies. This can happen when this is, for example, a solution for that problem we saw before with diamond dependencies. Multiple packages require the same package with incompatible versions. One takes less than 1, the other more than 1.5. This is how it will display to you the package that this is about, required by which package, and which version is installed, and which the other package wants. So cyclical dependencies are dependencies by basically say package 1 requires package 2, requires package 3, and then it requires package 1. It will detect them and display paths by which it found them. Missing dependencies are those packages that are not installed but are required by your environment. This can rarely happen in anything but the local environment, but it could happen if something has been changed and not propagated properly. Basically, if we uninstall 6 from Dante's dependencies, this is how it show you. Missing 6, and versions that are required by every other package that requires it. Any means does not set exact requirement at all. Now, validation is a bigger command. It does multiple things. Checks if all set requirements in the requirements files are set to a version or at least a version range. That is, if they are locked down from the top, if a maximum version is defined. Check if all locked requirements are set to an exact version in the log file. It will check whether package version matched the locked requirement version, since log files keep packages from the requirements files as well, but locked to the exact version. And check if all the required versions match the locked requirement versions. Now, we can also run it with a strict flag, which will check if there are additional packages in our environment that we're not actually using in our project. For example, IPython, as I used it before. This has caused an error if IPython is installed in the environment. This can be used on CI, for example, to check if we're not installing anything extra. This will also check if there are locked requirements that are not required by anything else. That is, if there are extras in our log files that do not need to be there. Now, it's recommended to use the strict file check whenever it's possible, but the problem can happen with testing in multiple Python environments where, for example, typing package is not necessary from 3.5 on. But it can happen in lower versions that you need it, and so requirements files can differ. Now, you can use check command to basically run all previous checks together. It's configurable in setup CFG. Exactly what checks do you want to run? All are enabled by default. And it's the command you'll use the most if you use Dante. A successful strict check will print out all of these. It will check every single one by one. All requirements are set. There are no locks in lock files that are not set. All package version match, and basically all that. Now, a lock command will display all packages that need to be in the lock file, or it can save them in a file by itself. So if you want to do, by default, it will use requirements lock, but you can override that name to anything you want in the configuration. If you want to use it for dev dependencies, all you have to do is pass dev.txt file to requirements and call save to devlock, and that's all it takes. We'll show you an example exactly how you turn your environment into something like this. This is how lock file works. It's basically, this is Dante's, for example. A lock file, it will only lock down all versions to an exact version, and that's it. Now, the graph function will display a graph of all your dependencies in your environment. It uses graph.viz in the background. You have to have it installed to render it, but you can use just the command to print out a dot file, which you can then use later anywhere. Now, let's see. This is, for example, Dante's dependency graph. We'll show you every package that's installed and dependencies relations to each other. For example, you see 6 is really used quite a lot, not for long, I hope. PyTest is there, all the other environments around him, and Flake just has its own little corner over there. And configuration, Dante config is a command that will print out your configuration in JSON format. You can read it easily without going to the files. Setup CFG, as I mentioned before, is used for configuration. This is an example of some configurations, some parameters you can configure for naming your log files and which requirements for log files it will go through to find to use for the check command, so you don't have to pass them every time. These are lists, so you can add multiple files for each. Here's a printout of the configuration in JSON. Since those previous tools I mentioned before are very opinionated and they only allow for a small amount of customization, I decided to go completely opposite route and allow almost anything to be configurable. So you can configure the name of the version that is not when it's not set, which is any. You can add checks that you want. And just list them here. Ignore list can be passed through when you call it, but also can be set here. Named versions is something different. When you use a feature branch, for example, and you build that, version could be, say, 0 point feature point something else. You can add patterns, which is basically regex just, that will ignore conflicts, since 0 point feature is it bigger than 2.0 or not? You can't know. So basically here you can add them as an override to make sure they won't break the build. And there are some graph configurations as well, which you can set up here, which are basically just GraphViz parameters you can set up. Now, setting up your existing environment to use Dante. It's not really complicated at all, but it's better to start with a fresh start. Clean out your virtual environment, or just start a new one, whichever is simpler for you. You install the packages that you use, which will be in a requirements file. You can install the development ones as well, since Dante can just tell you which ones are used where. Okay? So, if everything works right with those installed versions you have now, if you have tests, of course, you go on and set up Dante in CFG if there is anything you need to override. All of this will be, all the configuration options will be in the README. And you run Dante's log command to generate log files for those requirements files, which is, as you can see here, simple. For requirements.txt, if you haven't set them in the setup CFG, this is how it look. Requirements file, you can add multiple requirements files with -r. -s will save the file, and F will let you name it as you will. So we do this for normal requirements and development requirements, and now we use Dante check to check problems if there are any in the current configuration. So we just go through every single one of those that we mentioned before. Is everything locked? If they're unset, if there's mismatches between versions, conflicts, cyclic dependencies, and is there anything missing, and so on. When we set that up, we can use check to make sure it's everything fine, and that's it. You will get an environment that is very reproducible in anywhere you deploy it. Now, log files shouldn't be added manually. That should be left to Dante, and you will be certain that nothing unexpected will happen there. Now, you can set up Dante for CIs. All it takes, if you set up CFG, is to add a Dante check command. You can also use strict here, but failed checks will fail the build, since it will return 1 for any error that it finds. It will collect all errors first and then break, so you won't have to rerun the build 10 times. Okay, and it's a good practice to use it before PyTest, since it'll take a second. PyTest can take minutes. It also has an API module, so you can use it in your own libraries or applications to get dependencies, requirements, anything you like. For example, here we have retrieving of installed packages, just called dependency list. We can pass packages here, requirements files, whatever. We can get a single package just by using get, and get a requirement from a package. Basically, packages and requirements are defined as models in Dante itself. It basically imports everything from its operations module to the API, so you can use any internal call here. What requires a package, you will get by required by. You pass a requirement and a list of packages, and it will tell you every single package that is depending on that requirement and which version it uses. So you can do basically anything the CLI does through just programmatically. So it's very useful. It's still not perfect. Package hashes haven't been added yet, since they tend to be, since the tools for them are not yet that great. Hash, I'm not sure what the name is. It only supports adding hashes to your requirements files directly. You just type in hash in, I think it is, hash in name of the package, and it will add it to your requirements file directly. It won't just print it out. There's no option to just print it out. And pip itself, again, requires an archive of the package, so it can tell you its hash, which is not simple, but it'll probably be added at some point. Now, PyP packages can be deleted, which will still break the build. There's no simple solution for this. And lack of API on pip makes package management more difficult because we can't really write anything but a wrapper around pip for doing all of this job automatically. So it's still not that easy to manage, but this will make it a bit easier. Now, Dante is available on PyP. All you have to do is pip install Dante. The code can be found on GitHub under SVG organization. For now, only version 1 is available. This talk was about version 2, which will be available very likely in a week or something. Depends on the code review. Any questions? No? Okay. Thank you very much.